5.2 Properties of Exponents in Scientific Notation. So take a minute to look at these 7 properties of exponent. You have seen this in elementary algebra, and this is what we are reviewing again. So first thing, a lot of times we have difficulty on this type of problem is because we cannot clearly distinguish what is our base of this exponential expression. So first up, that my example 1 will be determining what are the base. So for the first example, example A, x to the 4th power, so the base is clearly x. For the second example, what is my base? Right? So this one you look at as negative 2 times x to the 4th power. So therefore, again, my base of exponent 4 is x only. If I want my base to be the entire negative 2x, I will write it as in example C. So notice that negative 2x is inside the parentheses. So the base of this exponent 4 in example C will be negative 2x. So hopefully that makes it clear for you how to look at the base of each exponent. So in example D, my base will be just z, because I can look at it as x times y times z to the 4th power. That's what I mean. And example E, my base will be y z, because it's inside the parentheses. Now we want to simplify these algebraic expressions, exponential expressions, using the properties of exponent. So first up, we cannot compute negative exponent. So therefore, I have to use property number 7 to rewrite into positive exponent, which will be reciprocating the base. So it will be 1 over 7 to the 3rd power. Now, computing 7 to the 3rd power with your calculator, or if you memorized it, that's very good, which is going to be 343. I would recommend you to memorize some of them. Okay. Next, so in this case, first I'm gonna change this negative exponent to positive exponent, which is gonna become negative 2x to the 4th power. And then I'm gonna be using property number 4. See, if you have a product in a base, the exponent is gonna apply to each factor. So that will be equal to 1 over negative 2 to the 4th power and x to the 4th power. So negative 2 to the 4th power, that is 16 x to the 4th power. And that will be my final answer. Next up, the exponent negative 4 is only for the base x. So 2 has nothing to do with it. So when I simplify this, it will become negative 2 and then reciprocating x, which will go down to the denominator. It will become your exponent is positive. And that will be my final answer, because you are looking at this direction, negative 2 times x to the negative 4. So when you change that negative exponent to positive exponent, the x will be go down to the denominator. So similarly, example D, I can write this as with the positive exponent, which is x times y over z to the 4th power, because the exponent negative 4 is only for z. And lastly, example E, it will become x over yz to the full power. So by reciprocating it, it becomes the positive exponent. And then you use property number 4, which is y to the full power, and then z to the full power. Continuing it, example F. So since 4 to the negative 5 is in the denominator, when you change to positive exponent, that will move to the numerator, right? This will move to the numerator, so it will become 4 to the 5 power. And then 1 times 4 to the 5th power. So 4 to the 5th power, if you use a calculator, that will become 1024. And times 1 is just 1. Similarly, right here, that will become y times x to the 5th power when I change it into positive exponent, which when you rewrite it, it will be x to the 5th power times y. Now, on the example H, y to the negative 5th power, so when you rewrite this to positive exponent, in the denominator I have x times with, when you change the positive exponent to the negative exponent to positive exponent, it will reciprocate. So the numerator, from the numerator, it will go down to denominator. So it will be y to the 5th power. Now remember, on the top, we can always say that times 1. So it will be 1. Because you cannot leave blank on the numerator of the fractions. So finally, my answer will be 1 over xy to the 5th power. Example I, to change into positive exponent from the denominator negative 5, when you change it into positive exponent, it will go to the numerator. For the y, from the numerator, it will go down to the denominator. So therefore, it will become x to the 5th power and then y to the 3rd power. So when you apply the negative exponent, you apply for each base. Similarly, for j, that will become w times x to the 5th power, and then y to the 3rd power come down to the denominator to become this. So hopefully you get better with this property number 7, because 7 is where most of us have problem. Okay. Example K. So it's a monomial times another monomial. So first, this is how we can look at it. Negative 5 times p to the 4th times negative 9 times with p to the 5th power. And next time I will not split it out like this. This is the first example to help you to recall. So next one, you can just multiply right away. Negative 5 times negative 9 will be positive 45. And p to the 4th times p to the 5th power, since it's the same base, you add the exponent using property number 1, it will be 4 plus 5. So my final answer will become 45 p to the 9 power. Similarly, for the next one, I can say that negative 3 times 7 will be negative 21. And x to the 2nd power times x to the 3rd power, so this is x to the 2nd plus thirds, right? Same base, you add the exponent. And y to the what? Negative 3 plus 2 using property number 1. So finally, my answer will be negative 21 x to the 5th power y to the negative 1 power, which we need to write it into only with the positive exponent. So that will become, using property number 7, to bring down y to the 1st power in the denominator to make it positive exponent, and this will be the final answer. Similarly, the next one, multiply 2 times negative 3/4, that will give me negative 3 over 2 because you reduced it. And then r to the negative 4 times r to the negative 5, so it will be r to the negative 4 plus negative 5 using the property number 1. And then s to the negative 4 plus 3. So this gives us negative 3 over 2 r to the negative 9 s to the negative 1. So finally, when we write it into a positive exponent, negative, in the numerator will be only left with 3. In the denominator will become 2r to the 9 power and s to the first power. And that will be my final answer. Because from this step to this step, we look at negative 3 over 2 times 1 over r to the 9 times 1 over s. So when you multiply everything, that's how you got it. The following examples are to practice on property number 2, because a lot of us tend not to use property number 2, and some problem is very easy when you see that. So property number 2 basically say that if you have the same base and dividing, then we have numerator exponent minus denominator exponent, and there's no more denominator. Everything goes to the numerator. So my final answer is m to the negative 5. And now using property number 7 to simplify, so it will become m to the 5th, which is 1 over m to the 5th power. Continuing this, the next, using property numbers 2, m to the negative 8 minus 13, which give me m to the negative 21. So changing into positive exponent, that become 1 over m to the 21 power, because they go to the denominator. Example P, m to the 8 power, numerator exponent minus denominator exponents, negative 13. So be careful. So it will be m to the 21, which will be my final answer, because it's already positive exponent. So by this property, example R will be much easier to attack, which is going to be m to the negative 8 minus negative 13 times with n to the negative 4 to the minus 11. Right? Numerator exponent minus denominator exponent. So this gives us m to the 5th power times with n to the negative 15. So changing this into positive exponent, which is m to the 5th power over n to the 15 power when you use property number 7. So I would recommend you have that property page next to you, okay? Whenever you do, when you're doing homework or any practice on this type of problem, because each step you need to use these 7 property, one of these 7 property correctly, so that you will get the right answer. So example S. So notice that the base of this exponent 4 is product, because we have a negative 2 times m to the 3rd power. So by according to the property number 4, the exponents can apply to each factor in the base. So 2 to the 4th power and m to the 3rd to the 4th power. Now 2 to the negative 2 to the 4th power is 16. Now m to the 3rd to the 4th power, that looks like in property number 3. So exponent to exponents, we multiply the exponent together. So this will become 16 m to the 12th power. So always go order of operations. So in this case, the next example T, and we will be using the property number 5. Going all the way back, take a look at property number 5, which is a quotient. If your base is fractions, the exponent is going to apply to the numerator and exponent is going to apply to the denominator. So for this example, t, my first step will be using property number 5. The exponent 2 is going to apply to the numerator and also apply to the denominator. So my numerator is 3x squared y, and then denominator is z to the second. So on the numerator, the base of this exponent 2 is a product, so using property number 4, that will be 3 to the second power, x squared to the second power, and y to the second power. And in the denominator is exponent to exponent, which is going to be property number 3, so it will be z to the 2 times 2 power. So finally, continue simplifying it. 3 to the second power is 9, x to the second power to the second power, x squared to the second power, that is x to the 2 times 2 using property number 3, and y to the second, and then z to the fourth. So final answer will be 9x to the fourth power, y to the second, z to the fourth. Then if you trying to review and then remember these property, I will recommend you write it down step by step. It will be a little bit longer, but you will see clearly what's going on and how to use each properties of the exponent. If you are already understood it, then you can skip the step. Okay. Example number U, letter U. So for this example, first I will take care of the negative exponent. So that will become 1 over negative 3y to the fifth power to the 2 power. And now I'm going to use property number 4, which is 3 to the second power, y to the fifth to the second power. So that gives me 1 over 9 y to the fifth times 2 using property number 3. So finally my answer will be 1 over 9 y to the 10 power. Continuing on the next example. So this example, you have to be careful. And notice that in previous example, I used property number 7 first because I only have the numerator. I don't have a denominator. Right here, I have both numerators and denominator. So I would say go to order of operations. So on the numerator, I'm going to simplify the exponent parentheses, which is going to be m to the second power to the negative 2 power, and n to the negative 2 power. In the denominator, m to the negative 3 and n. So this gives me m to the 2 times negative 2 using property number 3, and n to the negative 2, and m to the negative 3, and then n in the denominator. Simplifying a little bit further, that will be m to the negative 4, n to the negative 2, m to the negative 3, n in the denominator. Now I'm going to use property number 2, which is m, numerator exponent minus denominator exponent, times with n, the numerator exponent minus denominator exponent. There's no more denominator. And when I simplify that, that will give me m to the negative 1 power and n to the negative 3 power. Finally, change it into positive exponent. That will be 1 over m times n to the third, because both of the factor go down to the denominator. So next example, W. So similarly, I'm gonna take care of the numerator, which is 2 to the third power. We know that is already 8, so I will be saying 8 to the negative 2 power, and x to the negative 2 to the negative 2 power times y, and in the denominator is x squared, y to the negative 5. So continuing this, we cannot simplify negative exponent for uh, numerical base, so I have to change that into positive exponent by bringing down into the denominator. So this will become x squared y to the negative 5 times with a to the second power. And then on the numerator, negative 2 times negative 2y times y. So this gives us x to the fourth power times y. 8 times 8, x squared is 64, x to the second, y to the negative fifth. Now, continuing this, using property number 2, numerator exponent minus denominator exponent, y to the numerator exponent minus denominator exponent, and I still have 64 down there. So finally, this will be x to the second, y to the sixth, and 64. That would be my final answer. Last example, hopefully. Oh no, I have more. Okay. So follow the order of operations, right? So this will be 2y squared over x to the third. And I'm gonna uh, apply the property number 7 inside the parentheses first, because order of operation I want to simplify inside first. So it'll be negative 5 x goes to the numerator, x to the first power, and a y to the second power comes down. And notice that I'm simplifying the negative exponent inside the bracket. Now I'm going to simplify the negative exponent outside the bracket. So this will become 2y to the second over x to the third, which is going to be y squared, reciprocating the base, 5 to the first power to the second. Finally, I'm going to use the property number 5 on the second factor. So 2y squared x to the third, so first fraction stay the same, times with, I'm going to skip the step. No. Power to the numerator, power to the denominator. So finally, this make it much easier to continue, which is y to the exponent to the fourth power. Right? So this will be negative 5 to the second times x to the second, which give us 2 times y to the fourth times y to the fifth, so y to the second, so you add them up. Negative 5 squared is 25 times with x to the third power plus 2, because you add multiplying the exponent, so you add the multiplying the base, so you add the exponent. So this will become, my final answer is 2y to the 6th, 25 x to the 5th is my final answer. Continue. So example y and x are very similar, right? So we're gonna do the same thing. For the first factor, I'm gonna apply property number 7 for negative exponent negative 1, so this will become y to the third over 3x to the second, reciprocating the base. For second factor, I'm going to apply property number 7 inside the parentheses. So that means x to the third power in the denominator and a y to the second power in the numerator, because they reciprocated. Now, I'm going to apply property number 5 for the second fraction for exponent 3. So it will look like this: y to the third power 3x to the second times with 4y to the second to the third power and x to the third to the third power. Continuing this, using property number 4, that will become 4 to the third power and then y squared to the third power. In the denominator, exponent to exponent, so you multiply them 3 times 3. So which gives us y to the third power over 3x squared times with 4 to the third power is 64. And then exponent to exponent, we know that it will be multiplying, so 2 times 3 will be 6x to the 9. So finally, 64 over 3, and then y is multiplying the same base, so it'll be adding the exponent. Similarly, for the x part, x squared times x to the 9 power, so it'll be x to the 2 plus 9. And finally, my final answer become 64 y to the 9, 3x to the 11. That will be my final answer. It may seem long because I'm writing down step by step. And you should do that also to get used to with these property. Okay? And after you got with step by step, you can skip it very easily. So let me show it to you on the last example how I will skip the step. So first, I'm going to be using order of operations, so simplify inside the parentheses. So that will become reducing 4 and then 24. That will be negative 1 over 6. Simplifying the m using property number 2, that will become m to the 4th power. Simplifying n's using property number 2, so it will be numerator exponent minus denominator exponent, so which will be n to the 4 minus negative 7 is 11. Then last part, p to the negative 2 power over p to the 5th power, so using property number 2, p to the numerator exponent negative 2 minus denominator exponent, that will become negative 7. Now, simplifying inside the parentheses, right? Order of operation continuing, so that will be negative m to the 4th n to the 11 6p to the 7 power. Then simplifying the exponent outside using property number 7, that will become negative. Become positive exponent, you have to reciprocate the base. So when you're reciprocating the whole fraction, my base, that looks like this. And finally, using property number 5, 4 and 3 together, property number 5 applies this exponent to numerator and then denominators. So that'll become negative, and negative become positive. So no more negative. Okay. And applying to the numerator, that'll be 6 squared is 36. P to the 7 power to the second power is P to the 14 power. M to the full power to the second power is M to the 8 power. N to the 11 power to the second power is 22 power, and that is my final answer. So you can skip all those steps and then get the final answer very quickly and short. But however, you need to write down step by step in order to be able to do it mentally like that. Okay, so we'll practice it. That's what I will say. And last thing on this sessions, we want to talk about scientific notations. My interest is you can read scientific notation to a standard. You can convert scientific notation to a standard number and a standard number to scientific notation. And the other computation part, you can use calculator to do the computation. Right? So scientific notation is basically written in this format: a times 10 to the n power. It must be in this format. And where a is between 1 and 10, meaning it must be greater than or equal to 1 and less than 10. N is an integer. So let's write the standard notation. Standard notations, let me write it down step by step, and I'm going to talk about shortcuts so that you can use the shortcut next time. So this is basically talking about 2.51 times with 10 to the third power, that is just 1,000. So when we know that when you multiply by 10, 100, or 1,000, the decimal point move to the right. Right? The decimal point move to the right. Okay, what happened? 1,000. So move to the right 3 times, so it'll become what? 25. 2 more 0. Okay, move to the right 3 times, so 25. So right here, what you need to do is you need to put a note that if it is a positive exponent, right, and decimal points move to right. So when the n is a positive exponent, right, we move decimal point to the right. So take a look at on the second example. So this is basically means negative 6.8 times with, we don't know how to compute it by negative exponent, so it will be 1 over 10 to the 4, changing into positive exponent. So this is basically become negative 6.8 times with 1 over 10,000. So another way of saying is this is negative 6.8 over 10,000. So negative 10 to the negative exponent, that is basically same as you are dividing by 10, 100, or 1,000. So we know that if you are dividing by 10, 100, or 1,000, the decimal points move to the left. So for this answer, we're going to have to move the decimal point 4 times to the left. So it will be 0.00068. So let's put a note right here. Right? If it is a negative exponent, and decimal point move to left. Right? So if you understand that, then converting from a standard number to scientific notation or scientific notation to standard number is the same thing. So next up, we want to see standard number converted into scientific notation. So remember, scientific notation is in this format: a times 10 to the n power, and a must be between 1 and 10. So first thing is, how do I write this 29,800,000 into smaller than 10 and then greater than 1? So that means I have to put a decimal point in between 2 and 9. That makes it a number that is less than 10, greater than 1. Now I cannot change the value, so therefore I have to multiply by 10 to the some power. So how do I know I should put 10 to the positive exponent power or 10 to the negative exponent power? That's where you have to look at your decimal points, gonna move to the right or left to get back to the original number. So in this case, to get back to original number, I have to move my decimal point to the right side. So how many times do I move to the right side? 1, 2, 3, 4, 5, 6, 7. So therefore, it will be a positive exponent, which is from here. Okay, so that's how simple it is to write down the scientific notation. So let's take a look at on the second example and the last one. So this one, the number is very, very small, right? Smaller than 1. But however, when we write scientific notations, our a has to be bigger than 1 and then smaller than 10. So to make it bigger than 1 and smaller than 10, I have to put the decimal point between 5 and 0. And I cannot lose the original value, so it has to be times with 10 to the ascending exponent. Again, like before, previously, how do we determine it's going to be negative exponent or positive exponent? That's where I have to check my decimal point is going to have to be going to the left or going to the right. In this case, I need to go to the left in order to get my original number. So how many times to the left? So from here, so it'll be 1, 1, 2, 3, 4, 5, 6 times that I need to go to the left. So that will be negative 6 exponent. And that concludes this section.